Okay, everyone. So now we are learning the structure. To understand the structure, I am taking the example here. Let us assume that I am declaring one variable. So here I am writing int a. So I am assuming that there I am declaring a integer variable. So in the memory, there will be one block will be declared. Let us suppose that that block is having the address, let's say 301, and here the name is a. We know that here we have declared a variable of integer type. So I can only store the integer value. Let's say I am storing the integer value 301. If I want that, here I should store some other value. I cannot store. I can store only integer values. Now assume that I am declaring one array here. So let us suppose that I am saying char. We know that char is for the character. And here I am providing the variable that is n, which can contain 6 values. That means 6 is the size. So that means 6 blocks are reserved into the memory. We know that the name of array is mentioned as n, and let us suppose that the memory starting is 400. We know that here we are using the character, and character take 1 byte. So here the next address will be 401, then 402, then 403, 404, and 405. We know that here we are using the character array. That means in this array we can store only character elements. That means if I want to store my name here, let's say I am storing ANKIT. So this is the Ankit, and at the end we are providing the /0, which is the null character. So this is the character only. So here we should understand one thing, that if we are declaring one variable int a, that means it can store only integer values. And if we are declaring an array, let's say of character, it can only take the character values. Now, let us suppose that I want to create a record in which we should be having the employee name and employee code. So for every employee, we has to mark this. Let's say somebody is having the code which is 301 and maybe the name is, let's say, Ankit. So similarly, we can be having multiple employees here. Let's say this is 401, which is having the name that is Verma. So for the all employees, we need code and name. That means different data types are required, because we know that code we are taking into the integer, and here name we are taking into a character array. So this way we need different type of data type. So whenever we are combining the different data type into one, that is called a structure. So here what we are doing, we are simply providing the bracket. Inside the starting bracket, we are providing the int a, then character, let's say n6, then this is again the bracket close. So here afterward, we are putting the semicolon. So this part we are putting inside a structure. So for the structure, we are providing the keyword that is called struct. Struct means create the structure. Then afterward, we are going to provide the name of structure. Let's say we are saying it is the employee. So here we are providing the name of structure, that is employee. So here we are having the structure which contain one integer data type and one character data type. So character is the array here. So we can say that structure is the collection of different data types grouped together with a single name. So here we can see that we are having one, that is int a. So this int a is one data type which is of integer. Then afterward we are having is the char n6, which is the another data type which is character, and this is the character array n, which can contain 6 elements. So these two are clubbed together and they are given a single name, so that is employee. So here employee is having its code which is into the a and having its own name which is into the array n. So this is called the structure, means we are combining multiple data type, or we can say that the structure are used for creating the record. Record means whenever we are dealing with multiple data types together, let's say we want employee ID and employee name together. So this is one record. Similarly, we are having multiple records. Let's say we are having second record which is 401 employee ID and the name is Verma. So here this is the record 2. So here these records we are going to use with the help of the structure. Here there is one thing to note. It is depending upon the user that inside the structure what user is taking. Means user is taking, let's say, one integer variable a, or maybe it is a character array n. So depending upon the user, we are going to create the structure. That's why it is called the user defined data type. Means it is the user who decide which data type should be the part of structure. So here we can see that inside the employee, there we are having is the one integer data type and second one is the character data type. So there this is depending upon the user. That's why it is called the user defined data type. Now we are learning the declaration of structure, means how to declare the structure. For the declaration of structure, we are having is a syntax. First of all, we are going to use the keyword which is called struct. So whenever you are creating the structure, use the keyword struct. Now afterward, we have to provide the structure name. Then afterward, we will start with the bracket. So curly bracket start. Then afterward, we provide the type. Type means what is the data type. So first data type, and we are going to provide the variable. So here the first data type with the variable. So we are marking that variable 1. Similarly, structure contain multiple data types. So here again another type means a data type and maybe its variable. So here we are marking that variable 2. So similarly, we are going to provide the multiple types and their variables. Then afterward, we are going to close the bracket, and the most important, we provide the semicolon. So this is the declaration syntax. Now we are going to take one example. Let us assume that first of all we are going to provide the keyword which is struct. So here we are providing the keyword that is struct. Struct means create the structure. Then afterward we are having is a structure name. So here structure name we are providing that is employee, because we want that inside the employee there should be multiple data types. Then afterward starting bracket. So start with the bracket. Now type. So here we have to provide the first type. Let us assume that here I am taking a simple which is char. So here character is the first data type I am taking. Now assume that here the variable. Let's assume I am providing the variable, let's say n. So this is the simple variable n we are taking. Then again the type. So here we are taking the second type. Let's say I am taking the int. So int is another type. Then afterward variable 2. In the variable 2 I am, let's say, saying the code. So code means what is the employee code. So here n stands for name and code. So employee code and name we are taking, then ending with the curly bracket and semicolon. So here curly bracket end and afterward semicolon. So this is called declaration of structure. So here we have created a structure whose name is employee, and here we are having multiple data types. One is the character and second one is the integer. If somebody asks you what is the size of this structure, we know that size means how much byte it is taking. We know that character take 1 byte, integer take 2 byte, float take 4 byte. So what is the size of structure? We know that first we are using the character, and character use 1 byte. Then afterward we are using the integer. So here integer we know that it consume 2 byte. And because we are combining these two inside the structure employee, so if somebody asks you what is the size of employee, means how much byte it is consuming. So combine both of them. We know that 1 plus 2, that means 3. So 3 byte is the size of employee. So the structure is going to take the size depending upon its data type. So here character and integer, their combined size is the structure size, which is 3 byte. So here the structure we have declared that is of 3 byte. In the structure we are having next thing which is called the definition. Definition means we are going to define the structure variable or the object. For defining the structure variable or the object, we are having the syntax. First of all, we are going to write the keyword which is called struct. So here we are providing the struct as the keyword. Then afterward we are going to provide the structure name. Then afterward we are going to provide the structure variable. Then afterward is the semicolon. So now we are going to take one example. So first of all we are going to provide the keyword which is struct. So here we are providing the keyword that is struct. Then afterward is a structure name. So here we have declared the structure with the name that is employee. So here we are going to provide the name, that is employee. Afterward, we have to provide the structure variable. Let us suppose that I am creating one variable here, and let's say v. So here v is the structure variable. So this is how we can take the variable of the structure. In the structure, we are having this definition part extra. So here, whenever we are talking about the declaration, that means we are going to declare the structure. Means we have taken some data types, let's say character, integer, we combined them and we create a structure. Let's say the name is employee. Now, how to use that structure? To access that, we need to create the variable. So for creating the variable, that is called definition. That means define the structure variable. So here we are using the first line as it is, which is struct employee. So that line we are going to take as it is. Now afterward, we are going to take the variable v here. We know that just like we are having the data type int, and for that we create the variable, let's say x. Now similarly, here we are having is a structure user defined data type. So here we will use struct employee. So that complete name we will write here. Let's say struct employee. And this struct employee is acting like the user defined data type, just like we are having the system defined integer. Now afterward, you want to declare the variable. Similarly, you can take the variable, let's say v you are declaring, maybe v1. Here you are declaring, let's say y. You can declare, let's say v2. So in the same manner, you can declare multiple variables of the structure. You know that integer is the system defined, and here we have created the variables x and y. Similarly, struct employee, this is the user defined, and here we have taken the variable, let's say v1 and v2. So this is called the definition or defining the structure variable. Now the next part is the initialization of structure. Here we have learned the first part, that is the declaration of structure. Means we are going to declare the structure, and for that we have used the keyword that is struct, and we have provided the name of structure, that is employee. Many of the times people also say that this is the tag. Employee is a tag or the name. Then afterward we have taken the data types inside that. So we have declared one variable n, that is of character. So inside the memory we have declared, let's say one variable which is n. Let's say the memory address is 301. Now afterward we have declared one more variable. So that is code. So that is of integer type. So let's assume that here I am declaring one more variable. Let's say this is the name is code. And here, let's say I am providing the 307. So I'm assuming that this is the address. Now they combinedly are the part of employee. So employee is the structure we have declared. Then the second part is the definition. So here we are going to define the structure variable or the object. So here the first line we have taken, that is struct employee. So this struct employee is acting like a data type, and this data type is having the object which is v. So this object we have created. So with the help of this object v, we can access the structure. So this whole structure we can access using the object or the variable which is v. The next part is initialization, means initializing the values to the structure. Let us suppose that I am going to define a variable here. First of all, I am using the same thing. I am providing, let's say, struct. We know that struct is the keyword. Then the name of structure, we know that that is the employee. So here struct employee we have taken. Now here I am defining a variable, let's say v. So this part we have already done. Now afterward, if I say equal to, now a curly bracket start. Now the first value I am providing, we know that the first value is of character. This is the character. So here I am providing a single character, let's say A. We know that A is the character, that's why it will be into the single quote. Now afterward, second is the code. We know that code is of integer data type. Let's say I am providing the code which is 101. So this is how we are going to initialize the structure. So here we know that the first is A. So here inside the N we are going to provide its value which is A. Now afterward we are having is 101. So here code will be 101. So this is how we are going to initialize the value to the structure. And who is going to initialize? We are going to initialize using the structure variable. So here v is going to access. So with the help of v, we are going to access the structure and providing the values. So we can say that this structure is having its object, which is v. And with the help of this v, we are going to access the structure and providing the values to the structure. So here this is the initialization, or initialize the value to the structure. This is the first method of initialization. So by using this, you can initialize the structure. Now we are doing the second method. Let us assume that we have made the object or the variable of structure, which is v. So that we have already done. We know that with the help of this v, we can access the structure and here inside elements. So we will simply say v dot. So we know that the first element we are having is n. So here we are saying n. So v dot n is equal to, now we are providing, let's say, the value which is a. Now similarly, with the help of v, we can access the members of structure. So we are saying v dot, now we are providing the code. So here we are providing the name, let's say code. And we know that the value we are providing, let's say 101. So here the first option and the second option both are same. So anyhow you can initialize. You can provide into the curly bracket by saying a comma 101, or you can simply say that v dot n value is a, v dot code value is 101. So this is totally up to you how you want to use that. Both are exactly same. Now we are learning that how to access the structure elements. We know that we have created a structure. So this is the structure employee, which is containing multiple data type, let's say character and the integer. Now here we are having the elements, let's say n and code. So their values, let's say a and 101 if I want to access. So first of all, I will create the object. So here object will be created, that is v. We know that how to create that. First of all, struct employee. So this is like a data type, user defined data type. Then afterward v. So here v is the variable or the object of structure. With the help of this v, we can access all the members. So this v can access n as well as code and their values as well. Let us suppose that I am writing the printf, means printing on the screen. Then afterward I want to access the value. So simply we are going to write the v. We know that v is the object. So here v dot, afterward the name of element, let's say n. So we are simply saying v dot n. That means we are going to access the first element, which is n. So in the return we will get the value which will be a. Let us suppose that I want to access the second element. Simply we are going to write v. So here we will write v dot. Now afterward we know that second element is code. So simply we are going to write the code. And here with that, if we are going to use the printf statement, we will get the 101 as the output. So v dot n will result the value as a, and v dot code will result the value as 101. So this is how we can access the structure elements. Now we are going to take one real life example of a program. With the help of that we will understand that how structure can be declared, defined and initialized. So now we are learning this C program to create the structure. So here first of all we have given the comment that structure. So compiler is not going to read that because this is a comment. Then we have taken one header file hash include, which is a preprocessive directive, which is including the header file which is stdio.h, which is for printf and scanf functions. And afterward is the void, means no return type, main, which is a driving function. So inside that we are creating a structure. So here we are using the struct. We know that struct is the keyword. Then is the employee. So employee is the name of structure. So whatever is inside that, that will be the part of structure. So here the brackets. So this is the boundary of structure. Inside the boundary of structure, here we are having one variable which is code, that is of integer type. And we are having one array with the name, which can contain the 10 values. The size is 10. So here it is the character array. So character array and the integer. So these are the part of structure, which is employee. So this portion is called the declaration of structure. Just like in the C programming, we are having is the system defined data type. We know that that is the int. Similarly, here we have created a structure and we know that structure is the user defined data type. So here the complete line struct employee, this is acting like a data type. So whenever I want to create its variable, simply we are going to write the struct employee. So this is acting like the user defined data type. Now afterward, the next line is struct employee. As we know that this complete line is acting like a user defined data type, then afterward we are writing is A. That means this structure is having its variable, that is A. So with the help of this A, we can access the structure. So this is called definition. Definition means defining the structure variable. So here struct employee, this complete line is acting like the data type. Just like int is having the variable A. Similarly, if you want to create a user defined variable, you are simply writing struct employee, then afterward its variable say A. Whenever we are creating the variable of an integer, just like A, we know that inside the memory, we have reserved one block. Let's say it is having some address, maybe 301, and here the name will be A. But when we are dealing with the structure, so here we are saying struct employee. We know that this is a user-defined data type, so we are dealing with the complete structure. And its object A we are creating. That means here in this object or the variable, we should be having two parts. One is the character name and second one is the integer code, and character name is the array. So here inside this A, we are going to have the first part, which is the character array with the name. So here we are having the character array with the name. Let's assume that the memory is starting from 10 and here we are using character array. That's why 1 byte of storage for every character. So here 11, 12, 13, 14, 15, 16, 17, 18 and 19. So here this is the memory addresses where this is stored. Then the second part is integer. So here we are going to declare one variable code. So this is the code that we are going to declare. And here let us assume that it is having one block and maybe the memory address, let's assume it is having 30. So whenever we are making the variable of data type which is system defined, then only one block of memory is created. But whenever we are making the object or the variable of the structure, and inside that structure, whatever the parts are available, which is the character array or the integer variable, then both will be created. So here this A belong to name and code. So here these two things we want. Now after that we are having is equal to, then curly bracket start, then here we are initializing Ankit, then comma 101, then curly bracket close and semicolon. So here we are going to provide the values. So this is called the initialization. So here starting from equal to until the end, here we are providing the values. So this is called initialization. So here we are saying the first value, which is Ankit. So that means inside the name which is belonging to A. So understand that the variable A is having name and that name is having the value which we are giving that Ankit. So here I am giving my name. So that Ankit is stored inside. At the end automatically /0, which is null character, is applied. Now after that is 101. So here variable A and that code. So this code is belong to variable A, which is having the value which is 101. So here this is the initialization, means we have initialized the value. Now the next part is displaying the value or accessing the value. So we are saying that printf means printing on the screen, %s, that is for the string. So here from A dot name. So understand that A is the name of variable and with the help of this A we are accessing its name and we know that the name is Ankit. So here this we are going to provide to percentage S means display the string. So here Ankit will be displayed on the screen. Then afterward we are having is the percentage D, which is for the integer value. Then afterward we are having a dot code. So from the variable a, which is a structure variable, we have the code. So here this code we have taken and we have shown. So here a dot code we have given to percentage D. It is showing the 101. So this is how we can declare, define and initialize a structure, and we can show its value. In this program, we have defined only one variable of the structure. But let us suppose we want to define more variable, then how it will happen? So take the example of int. We know that whenever we are using the int, at that time we provide the variable, let's say a. So we already know that, we have learned with that. So for the next variable, we provide comma, then the name of variable, let's say b. So what is going to happen? So inside the memory, one block will be declared, and that will be the b. Let's say the address is 401. But let's assume that I want to define the variable for the structure. We know that struct employee, this complete line is the user defined data type, because declaration we have already provided. A, we have already learned. A is having its name and code, so we have initialized. Now let us suppose that I want to define one more variable of structure. So I will write comma b. Now by writing this, again their name and code, they will be declared, because these two are the part of variable b, which is the variable of structure. We know that name is the array which is of size 10. So here in the name, 10 memory blocks will be reserved, and we know that code is again the type integer. So here one block for the code will be reserved. Let's say its address is 40. Just like for the variable a, we was having the name and code. Similarly, for the variable b, we are having the name and code. That means if you are making the multiple objects or the variable of a structure, then their memories will be different. So here again we have to initialize. So I am changing the code here. We know that already we have used struct employee. That means this is a user defined data type. Then afterward a. So here this a means we are going to define a variable. Then let us suppose that afterward we are going to provide the comma and we are writing b here. So by writing this, we have defined one variable b who is having the name and code. So that memory is reserved. Just like for the variable a, we have given the values. So Ankit and 101, these values we have already given. Similarly for the b, we have to initialize the value. So here b with the curly bracket, let's say we are starting and saying Verma here. Then afterward double quotes, then comma 102. So here the initialization is also required for the b. So here in the b, we can access the name, and name we are going to provide. So here we are going to write Verma here. So this will be written inside the array, which can be accessible using the b, and at the end we are providing /0. In the same manner, 102 will be the part of code. So after initializing the value to the second variable of structure, now we are going to access its value. We know that in the same manner, we are going to write the printf statement. So here we are writing printf. We know that printf means printing on the screen. Then afterward double quotes %s for the string, then %d dash for the integer value, comma, we know that here we are having is variable b. Variable b is of structure, which first part is name. So we can say that take b dot name. Then afterward we know that comma, again variable b. So this variable b is having the second part, which is code. So we can write here b dot code. So by this we can access the value. So here printing on the screen b dot name. So b dot name value will be displayed, and we know that b that is b dot name, and the name is Verma. So here on the screen we will be having that Verma. Then afterward we are having is b dot code. So there b dot code will be going to the percentage d, which is the integer. So here b, which is the variable of structure, and b contain the code. So here that code we are displaying, that is 102. So this is how we can create the multiple variables of the structure. In the structure we are having is the first part, that is declaration, means declaring the structure. Then is the definition. Definition means defining the variable of the structure. You can create one variable or more variable depending upon your requirement. Every variable can have the same types of the structure member. Just like A is having its own name and code, similarly B is having its name and code. So they are separate. So separately they will be initialized, just like Ankit and 101 and Verma and 102. Then afterwards separately they can be accessed. So that is all about the structure.